Today is the second part of our interview with Lou Ekus, the CEO of Tropic Marin, and we will start with another part of our questions. The second part is element supplementation. First of all, I want to ask you to tell more about different methods of major element supplementation, like classic balance method or very popular two-parts method.
Yeah, so when we're talking, by the way, Alexei, always remember, I'm the CEO of Tropic Marin USA.
USA, yeah.
This Tropic Marin is a much larger company. I just do US.
Just to be correct.
Yeah. So when we're talking about the balling method or the two-part method, we're basically talking about the addition of the supplementation of calcium and alkalinity. Many people confuse the balling method with the modifications that have been made to the balling method that are not really balling method. Balling method does not supplement trace elements, and balling method does not supplement magnesium. Okay. Now, it's important to make the distinction between supplementation, which is adding additional for what has gotten used, and just adding. Because technically the balling method does add magnesium and it does add trace elements. However, it doesn't supplement for used magnesium and it doesn't supplement for used trace elements. All of the magnesium and the trace elements that you're putting in just go to balance what is left from the part A and B. So you're not making up for any of that stuff being used. Okay. Now, the easiest way for me to explain about the two-part method and the balling method is to show you a little graphic. So let me share my screen for you.
Okay.
And let me bring up this graphic. You should hopefully now have calcium chloride and sodium carbonate.
Yeah. Maybe take that. Yeah.
All right. So the easiest way to understand the balling method is to first understand the two-part method and what the issue is, what the problem is that the two-part method creates. So first we're going to talk about the two-part method. Now, the basic two-part method is this. You have a part A, which is, oops, sorry. My sharing didn't work. Hold on a minute.
Yeah.
You have a part A, which is calcium chloride. Then you also have a part B, which is sodium carbonate or sodium bicarbonate or some combination of the two, depending on what company's products you're using. Now, there are companies that make products that they call balling light, balling plus, that start like this and add other stuff. I'm not talking about any of those. I'm just talking about the basic two-part method with calcium chloride and sodium carbonate or sodium bicarbonate. I'm using sodium carbonate here just because it keeps the explanation simple. Okay. What happens when you put these solutions in is that the calcium from the calcium chloride and the carbonate from the sodium bicarbonate will be used by the corals with the help of the zooxanthellae to make their calcium carbonate skeleton. So these things are going to go down in the coral. They're going to be gone. We're done with them. They're out of the equation now. Now, there is nothing you can do about the fact that if you start with calcium chloride and you get rid of the calcium, you're left with the chloride. And if you start with sodium carbonate and you get rid of the carbonate, you're left with sodium. They're not going to evaporate. They're not going to disappear. Now, in one way, this is very convenient because chloride and sodium have a tremendous chemical affinity for each other. They love each other. And they form what we know is sodium chloride. And sodium chloride is just salt. Now, 70% of what is in sea salt, approximately, is sodium chloride. So you're not creating anything bad or toxic. You're just creating a little bit more of what is already 70% of what's in your tank. But here's where the problem comes in. As you continue to add more and more A and B, you're going to create more and more sodium chloride. Now, I'm going to just stop my screen sharing for a second and bring you back again, because this part of the explanation is best to do with my hands.
Okay.
And you have to excuse me because I had hand surgery yesterday, so I have a bandage on this hand. But think of it this way. In your saltwater tank, there is 70% sodium chloride and 30% other stuff. And I'll grant you the bulk of that other stuff is magnesium, but there's also 70 trace elements in that other stuff. And your animals want this 70 to 30 ratio, 70% sodium chloride to 30% other stuff. This is going to be my sodium chloride hand. The one with the bandage represents the sodium chloride. The other one represents the other 30%. Now what happens is you keep your tank at 1.025 or 1.026, and what you're measuring when you're measuring that is how much of this stuff is in the water, okay?
Okay.
Even if it's a higher salinity, it's still 70-30 ratio. Now, with the two-part method, we're going to add a bunch of sodium chloride. We're not adding the other 30%. We're just adding a bunch of sodium chloride. That makes your salinity go up. So what you do is you add fresh water to bring the salinity down. But when you dilute this, you don't selectively dilute the sodium chloride. You dilute everything so that the average of these two things is still 1.026 or 1.025. But what's happened is you have now more sodium chloride and less of that other 30% than you had before. So you have maybe, instead of 70-30, maybe you have 75-25. I'm exaggerating a little bit, but I'm just exaggerating to make the point. It's probably more like 71 and a little bit less. You know, it's very little, but it still is a change in the ratio. Now, if you add more sodium chloride and you dilute it again, and you add more sodium chloride and you dilute it again, you're still at 1.025, but you have like 80% sodium chloride and 20% other stuff. Look where my other stuff hand is. It's going out of the picture because it's getting so low. The basic idea here is that if you keep your salinity constant and you raise the amount of sodium chloride, you must have less of everything else that your animals want. And what that everything else is all those important trace elements and your magnesium. Now, some people say to me at this point, well, I measure my magnesium and I add so that I keep it up. Okay, that's fine, but that means now that you're pushing all your trace elements down even further. Even further, because you're also not just adding the sodium chloride, you're also adding magnesium. So that pushes your trace elements now down even further. That's the basic problem with the two-part method, is not that it doesn't add the calcium and the alkalinity, it does. But in the process, it throws the ionic balance of the tank off and gives you more sodium chloride and less of everything else your animals need. Okay? All right. Now we're going to go back to our screen and we'll see how the balling method fixes this. It's actually quite brilliant and quite simple. So here is that excess sodium chloride that we created, right?
Okay.
So now this just shows you there's lots of different ways to deal with this. These days we have all for Reef, we have carbocalcium. We're going to talk right now about the balling method. You can also use a calcium or a calc reactor. These are all different ways that we can deal with this. So the reason I include this slide is just because I want to make the point, I always want to remember to make the point that There are lots of methods called balling something, balling plus, balling light, balling whatever.
Mm-hmm.
The only thing that works the way I'm explaining to you is the true balling method. And the true balling method was created by Hans Werner Balling in 1994. It was revised by him in Dots magazine in 1996.
Mm-hmm.
He now is the head of product development at Tropic Marin, and the only place that you can buy the true original balling method is if you're buying the Tropic Marin A, B, and C. Sorry for the plug there, but it is the case, and a lot of other companies make products that are balling that are not actually the balling method. So, in the balling method, here's what we do. We have the calcium chloride in the part A, just like the two-part.
Okay.
We have the sodium carbonate or the sodium bicarbonate in the part B, just like the two-part. But what Hans Werner did in 1996 that was so brilliant was that he added the part C. Part C is everything else that's in sea salt, but no sodium chloride, no alkalinity, and no calcium. So it's that other 30%. And the way it works is this. Just like the two-part method, the calcium and the carbonate go down into the coral skeleton. That still leaves us with the chloride and the sodium that still create sodium chloride. But now, instead of just building the sodium chloride, we're going to also add the other 30%. These two things together just make complete sea salt. So once you add that, your salinity still goes up. Let me get rid of our screen sharing again. Bear with me here a second.
Yep.
We saw in the two-part explanation that we had the sodium chloride, the other 30%. We added sodium chloride and diluted. We added sodium chloride and diluted. So the sodium chloride went up and the trace elements went down. With the balling method, the same explanation, we still add the sodium chloride, but now we also add the other 30% so that when we dilute it now, it comes back right to where it started. So the salinity still goes up, but it goes up in an ionically balanced way so that when you dilute it, it comes back right to where you started. Now, this is why you're adding, technically, with the balling method, with this other 30%, you are adding the trace elements and the magnesium. But you're only adding enough to offset and balance the sodium chloride. You're not adding any that is going to supplement. So when you're using the true balling method, you still have to add trace elements and you still have to add magnesium.
Okay, I have a couple of questions.
Yes.
First of all, why can't you put everything which you have in component C into one or into first or second part?
Because it precipitates. If you add calcium and alkalinity together, you get calcium chloride.
No, for example, if you add magnesium to first part and trace elements to the second part and have two-part solution.
You can add, well, the magnesium I like to do separately, and I'll explain why. You actually can add the way we separate the trace elements into trace A and trace K, which we haven't talked about yet, but I assume we're going to talk about it at some point. You actually can add the trace K to the balling A and the trace A to the balling B. You cannot add the trace A to the balling A, but you can add the trace A to the balling B and the trace K to the balling A.
But in fact, they are all together in component C.
Yes, but in very tiny concentrations. Not enough of a concentration that they will precipitate. Where if you just add them together, they will precipitate. And it's not a good way to think of it that they are both in part C because they're not Well, they are really, but there are 70 trace elements in part C.
Mm-hmm.
There's only 17 trace elements in A and K together.
Mm-hmm. In much higher concentrations.
Yes.
Mm-hmm.
And the reason we only put 17 is because all 70 trace elements don't go down at the same rate in reef tanks.
Mm-hmm.
There are 17 that go down very quickly, and that's why we make our trace element product those 17. You don't want to use part C of the balling method as a way of adding magnesium or trace elements to the tank.
So it's not correct to use it.
Not to add magnesium and trace elements. All you use part C for is to ionically balance the leftover sodium chloride from the part A and B.
Okay, and component A and component B can be used for additional supplement of calcium and alkalinity.
Yes.
So
yes, and although it's always explained in the balling method that you use equal parts of A, B, and C, it's not 100% necessary to do that. So let me explain about that for a minute.
Mm-hmm.
The solutions of A, B, and C that we recommend you make, those concentrations, will match what we call the stoichiochemical ratio of calcium to alkalinity that the corals will be using in their calcification. So if the only calcium and alkalinity that you have to add to the system is the calcium and alkalinity that the corals are using, then it'll work perfectly to use equal parts of A, B, and C.
Mm-hmm.
Now, in many systems, the system might use more alkalinity than that. That's the most common thing. Or maybe it uses more calcium, but in most cases, it's the alkalinity that it uses more, because there's a lot of things that can use alkalinity that have nothing to do with calcification. So some tanks use way more alkalinity than what the corals are using. And in that case, you might need more of the B solution. So maybe you're adding 50 milliliters of A and 75 milliliters of B every day to the tank. In that case, you would add 50 milliliters of C. So you have your C volume match whatever the lower number is of A or B.
Mm-hmm. Okay, and if I add more of A or B component, what to do with the excess, for example, natrium ions or maybe chloride ions?
You don't worry about them. You don't worry about them because, number one, it will be a very, very small amount. And number two, if there's extra, for instance, if there's extra sodium, there's no chloride to make the sodium chloride. So you just don't worry about it. You just, if there's differences in amounts, don't worry about that little extra sodium or that little extra. There's so much chloride in the tank anyway. There's so much sodium in the tank anyway. It'll be a very, very tiny percentage extra of that one thing. You don't even worry about it.
Okay, but if I have, for example, a tank without water changes, and in a long distance, there is more and more and more sodium.
Yeah, well, it's part of the reason that I'm not a fan of never doing water changes. I think it's a good idea to do water changes once in a while. I'm not one of these people that says you have to do 20% every 2 weeks, or 10% every week. I don't agree with that. But I also don't agree with never doing a water change. In fact, on Friday, I'm speaking at the Brooklyn Aquarium Society about water changes. Because water changes they're the best equalizing factor. They're the best way to do something positive for the tank that you know you're doing something good, even if you don't necessarily know exactly what it is. I'm a firm believer, and I have no scientific basis for this whatsoever, so this is all just my theory. But I have a theory that the chemical compounds in the tank don't stay in exactly the same molecular form forever. So in other words, my theory is that sodium chloride doesn't look the same on the day you add it as it does 10 years from now. I think it changes its molecular form a little bit. I don't know. I don't have a good explanation for it. But I think that a water change is literally like a breath of fresh air for you and me, but breath of fresh water for your animals. I don't have a reef tank right now because I travel too much and I don't have time to maintain a reef tank. So I keep easy things like African cichlids and mangroves. But when I did have a reef tank, there was one thing that was 100% consistent. And that was every single time I did a water change, my animals looked better the next day. 100% of the time that I did a water change, my animals looked happier the next day. And in my world, if there's some button I can push that makes my animals look better, I probably should push that button once in a while. And to me, that's a water change. Am I 100% sure that I understand exactly what it does? No, but I know my animals like it. So I'm going to do it once in a while. Maybe it's once every 3 months. Maybe it's once every 6 months. I don't know. But I'm not a fan of the approach of never doing water changes. I think even when you're using the balling method, it's a good idea once every few months to do a 20% or a 15% water change. And you look at your animals the next day, you'll see they look better the next day. They like that. And how many things can we do in our reef tanks that makes our animals happier the very next day? Very little.
Very little, yeah. So maybe.
So I'm a big fan of doing water changes once in a while, and so I don't worry about that little extra amount of sodium or that little extra amount of chloride that would be only a little bit because maybe you're adding 50 milliliters of one and 60 milliliters of the other. It's a very, very small amount.
Okay, thank you. So you told about that you need to dilute your salt water to compensate the salinity. How you should do it? You should take some salt water out of your tank and replace it with reverse osmosis water.
Yeah, I mean, in general, if we talked about water changes. If you're doing regular water changes, you don't even really notice it because the water changes will make up that difference. You know, they're going to change that little bit percentage. And when you check your salinity, if it's a tiny bit low, you make your water change water a tiny bit more, higher. If your tank is a little tiny bit high, you're going to maybe change water with, 1.024 instead of 2.5. If you're doing regular water changes, you don't even really notice it. If you're not doing any water changes, you probably will notice it in a few months. And then it's a matter of taking a little bit of salt water out and putting a little bit of RODI water in. But I don't know if many people do that because even if you're doing a water change every 3-4 months, you're going to fix it just kind of in the process of the water changing. So it's really almost not even noticeable. Okay,
thank you. So you promised to tell about why you don't like to supply magnesium together with calcium or alkalinity.
Yeah, it's very simple. The trace element usage will be proportional to the calcium alkalinity uptake. Okay, if the animals are doing more calcification and they're growing faster, they're going to use more trace elements. So It's okay, in my opinion. I like to do this, to put the A and K in the balling B and A, okay? Because if they're using more B and A, they need more A and K, okay? Magnesium usage is different. Magnesium usage is not always proportional to calcium alkalinity usage. So just because they're using more calcium and alkalinity doesn't mean they're going to be using more magnesium. Or just because they're using less doesn't mean they're going to be using less magnesium. And in fact, I have worked with plenty of tanks, and this is another one of those things I have no explanation for this. But I've helped a lot of people that they have a reef tank, been running for a long time. It's been running for 3 years. It's never used a lot of magnesium. All of a sudden, it start using so much magnesium that they can't keep ahead of it. They're adding a maximum dose every day, and the numbers are still going down. And no matter how much magnesium they add, they can't seem to get the numbers up. And then all of a sudden, 4 or 5 or 6 months later, now the numbers are going up, and the magnesium usage pretty much stops. I have no idea why this happens. I can just tell you, I have seen it happen many, many times. The bottom line is that I like to keep the magnesium additions separate, because then it leaves me to have the control over how much I'm adding separately. So if the tank's using a lot, I can add more. If the tank's using less, I can add less. I don't like to tie it to the calcium alkalinity uptake.
Okay. So let's go on. Okay. Let's talk about the more modern ways of elements implementation. And the first one is carbocalcium.
Yeah, so with carbocalcium, it's a calcium formate product, like our All for Reef is a calcium formate product. And this is quite different than the traditional way of adding calcium alkalinity. Instead of adding the calcium chloride and the sodium bicarbonate or sodium carbonate, you're adding calcium formate. And what happens is that the calcium goes into solution, and then the formate is metabolized by certain beneficial bacteria into the carbonates, into the alkalinity. And what's interesting about that is that much of the bacteria that does this conversion lives within the coral polyp itself. So when you add calcium chloride and sodium bicarbonate to a tank, you can see both the calcium go up in the water column, and you can see the alkalinity go up in the water column because you're adding carbonates. With calcium formate, you're kind of bypassing, for the most part, not 100%, but a certain percent of the carbonates, the alkalinity that you're adding, is kind of bypassing the water column. It's going directly into the corals, because the formate goes into the corals, and this conversion into the alkalinity that the coral needs, in large part, happens within the coral polyp. So instead of seeing the alkalinity go up, you just don't see the alkalinity change. It doesn't go down, because the corals don't need to take it out of the water column, because they're getting it from the formate. Does that make sense?
Yeah.
Now, eventually, you will see some of the carbonates go up in the water column, because there's bacteria on the skeletons of the corals and external that also do this conversion. But in general, in the beginning, you don't see people are used to adding carbonates and seeing the alkalinity go up immediately. But in general, with the formate, you don't see that. You don't see the alkalinity go up, but you also don't see the alkalinity go down, because the corals are getting it. And then eventually you do see it start to go up in the water column as well. But that's why there's that lag time with the alkalinity being seen in the water column, because the corals just don't need to take it out of the water because they're getting it directly.
Okay. So carbocalcium can help you to supply calcium and carbonates. Does it contain anything else, or it's just clean calcium formate?
No, it's just calcium formate, and it supplies calcium and alkalinity, and that's it.
What other products? Oh, okay. What other products can be used with carbocalcium to supply, for example, magnesium or trace elements? For example, can you use part C of classic baleen together with?
No, you can't use the part C. However, remember I said you don't want to use the part C of the balling method to supply trace elements or magnesium. All right, and that's because the proportions aren't correct. You just don't even you think of it in that way. Think of it more in the way that the part C is only good for balancing the excess sodium chloride from the part A and B. That's all it's good for, okay? However, let's talk about Reef for a minute, and then we'll come back to carbocalcium, okay? Once we figured out about the calcium formate being able to supply calcium and alkalinity, we then realized that we could also add to the calcium formate trace elements with our A and K, and magnesium with our biomagnesium to make Reef. So Reef is one solution that contains your calcium, your alkalinity, the trace elements, and the magnesium. So you're getting all of that in the one solution. The disadvantage, the disadvantage of having everything in one solution is that your tank may not use those items in those proportions. And in that case, one or more things go out of whack. So originally we said, use Reef in smaller systems, because in a smaller system, in general, you're doing a larger percentage water change. So if things go out of whack a little bit, it's not as important, because if you're doing a 30 or 40% water change, you're going to fix that. So the Reef was originally meant for smaller systems that were being used that were getting bigger water changes, and carbocalcium was meant for larger systems that weren't getting those big water changes. Okay? Now, what you can do, though, in a larger system, the thing I like to do in a larger system, is to take the carbocalcium, make the solution of carbocalcium, and then add the A and K trace elements to the carbocalcium. Now, the reason you can add A and K together to the carbocalcium, because you can't put A and K just together. They'll precipitate. But the reason you can put A and K in the carbocalcium is because the carbocalcium is an extremely concentrated solution. So it prevents the A and K from precipitating, plus you're not putting them in full strength. You're just putting in a little bit A and K so they don't precipitate. If you put the A and K in the carbocalcium and you leave the magnesium separate, now you have the calcium and the alkalinity from the carbocalcium, the A and K for your trace elements, which is all proportional in its usage. And then in the larger system, you add the magnesium separately, so you have control over how much goes in.
So you can use 2 dosing pumps, one for carbocalcium with elements, and the second for magnesium.
That's the way I prefer to do it in a larger system. And then in the smaller systems that are getting bigger water changes, the Reef is super simple, because you got one solution that does everything. And I will say that we have a number of people that are using Reef in very, very high dosage, over our maximum recommended dose that see no magnesium imbalance. Now, I don't really understand how they don't see it. I don't understand why it's not there, but it doesn't, this is one of those things that looks one way in theory, but seems to look a different way in practice.
Okay.
So in theory, you should get a magnesium imbalance when you're doing that, but in practice, it doesn't seem to happen.
There is a lot of such strange things in Reef Aquarium.
Yeah, absolutely. And this is why we came out with the powdered form now of the Alpha Reef, because we have so many people using Alpha Reef in the larger systems that wanted a less expensive way to be able to mix it up. So now we have the Alpha Reef in the powder because we have people using it in much larger systems than we expected.
Okay. Can you say a few words about biomagnesium? What is it? How can it be used?
You use it to, you can mix it into a solution and dose it, or you can add it as a powder to the sump. It supplies the magnesium plus some few trace elements that are used when the magnesium is taken up. So the reason we do that is so that you're sure to cover a little bit of that trace element usage that's going to happen because of the magnesium that goes in. But other than that, it's really, the thing about magnesium that's so hard for people to kind of get their head around is that you're working with such large numbers that when your magnesium goes down, it's very hard to get it up. If you think about calcium, we're talking about 400 parts per million. So if you add 100 parts per million, it goes up very quickly. But when you're talking about magnesium, where you're talking about 1,300 parts per million, you add 100 parts per million, it doesn't seem to go up so much. So people that have low magnesium levels keep saying, oh, I'm adding magnesium and adding magnesium, it's not going up. It's very hard sometimes to get that magnesium up. You have to work for months with maximum dose to get it up because you're working with such higher numbers.
Okay. And is it in mineral form, or why it is called biomagnesium? What does it mean?
It's just, no, we just call it biomagnesium because at one point we had what we called the bio line and the pro line. It's just an old name from the company.
Okay, so we already started to talk about Alpha Reef. So let's continue. The most popular question about Alpha Reef is how to establish a correct dosage. What component or maybe what test should you use to check if you are okay with Alpha Reef? Maybe alkalinity or calcium?
Yeah, very, very tough to say. I'm going to give you a two-part answer to this. We even argue a little bit about this internally in the company. We have some disagreement as to, I disagree with Hans Werner a little bit about how we do this. What I would say is this. If your tank tends to use more alkalinity, then it's better to use the calcium as the determining factor for the dose.
Calcium. So not, okay.
Because if you use the alkalinity, then you'll end up with excess calcium and excess magnesium and excess trace elements if it's using more alkalinity. So if your tank tends to use more alkalinity, I like to use the calcium as the indicator for the dose. And then if your alkalinity is running a little low, then you use some Balling B to boost the alkalinity. If your tank tends to use more calcium, then it's better to use the alkalinity as the determining factor, and then you add a little bit more calcium with the Balling A. Does that make sense?
Yeah.
Okay. Now, the only downside to doing that is that it's way easier to measure alkalinity than it is to measure calcium. So it would be very convenient if you can use the alkalinity as the measure. Mm-hmm. But in tanks that use a lot of alkalinity, you end up with higher calcium is too high because you're putting so much in for the alkalinity. The other reason I like to use the calcium is because when you add the Reef, the calcium shows up very quickly. The alkalinity doesn't. So if you're using something like a KH director to regulate it, you have to set that KH director on the maximum delay. There's a setting for the when it makes a dose and then when it takes the measurement. Okay. You have to set it on the maximum delay. And even doing that, sometimes you end up with some excess calcium if your tank uses a lot of excess alkalinity. Mm-hmm. Now, that being said, if your tank is using a lot more alkalinity than it is calcium, then we should find out why that's happening. That's usually a result of one of three things: bad circulation, bad aeration, or CO2 pooling. It's usually one of those three things.
It's like pH problems.
Yes, it's a lot like a pH problem. So if you're having those issues where the tank is using, you're doing the balling method and your tank is using 20 mLs of A, but it needs 40 mLs of B every day, we should be looking and finding that problem so that the excess alkalinity usage goes away.
Usually people say like all tanks are different.
It is true that all tanks are different, but it is also true that the corals will use a certain amount of alkalinity to every unit of calcium. And that is what the balling method solutions are designed to do. So if you're using a lot more alkalinity than that, there's a reason for it. And that means that the tank is using alkalinity that is not for calcification. And then we have to find what that reason is. Sometimes it's an area of detritus that has accumulated in a sump or behind a piece of coral somewhere. Sometimes it's CO2 in the house, and you need to run an airline from the protein skimmer out a window. I mean, there's a lot of different reasons. But if you're using a lot more alkalinity than calcium, we should find out what that is from.
Okay. Is it correct that eventually your Reef aquarium should use all these parts in a standard amounts?
In a perfect world, yes. But it is rarely a perfect world. And most of the tanks that I help people with use a little bit more alkalinity than they do calcium.
And maybe
so
if you
I don't think it's a problem. But if it's using a lot of alkalinity, twice as much alkalinity as it is calcium, then we should find that, because eventually that will translate to you fighting with pH, which is going to be more serious. So we should find that problem and fix it so that you don't run into the pH problems later.
For example, is it possible that if you have, for example, a lot of clams, your magnesium consumption is much higher?
Could be. I don't know for a fact about that, but it could be.
Some people say that if you have big clams, they use a lot of magnesium.
Yeah, okay. I don't have experience with that, but it could be. But even the clams should use the equal proportions of calcium and alkalinity. Magnesium, maybe not, but calcium alkalinity, yes.
Okay. Another popular question. As Reef becomes more and more popular, people ask, is it more expensive than classic baling or even calcium reactor on Reef with high element consumption? For example, if you have a full tank of acroporous, so on.
Well, I'll say this much about it, because this is very dependent upon what you can buy the products for. And in different areas, it costs different amounts. So, but I will say two things about it. The calcium reactor is a little different. And in all cases, the calcium reactor, your big bulk of your money is spent up front in getting it set up. Mm-hmm. And maintaining it is probably going to be less, always. Mm-hmm. But your big expenditure is going to happen up front. In relation to balling, the Reef and carbocalcium are about twice as concentrated in the calcium and alkalinity than the balling methods are. So you're going to use less. You're going to use about half as much. So depending on what you can get it for, you can do that calculation and figure out, what it's going to cost you. But you're going to use much less carbocalcium or Reef than you do of balling because it's more concentrated in the calcium and alkalinity.
Maybe by your experience in the US, is it cheaper or more expensive?
To be honest, I've never done the cost comparison.
Okay.
I don't know the answer to that one.
Okay. Another question from me.
And, Alexi, I'm gonna say one more thing about that. Mm-hmm. To me, it makes more sense when you have a reef tank. It makes more sense to look at how do you want to run your reef tank rather than looking at cost. Okay? And the reason for this, the reason I say this is because a lot of people come to me and they say, oh, I have a 300-gallon reef tank and I'd love to use your salt, but your salt is too expensive. Mm-hmm. Well, if you're going to put up a 300-gallon mixed reef, you have to understand that you're going to have a certain amount of ongoing cost. Mm-hmm. It's like if you buy a Ferrari or a Maserati, you don't go and buy the cheapest oil and the cheapest gas you can get to put in it.
Or Mercedes-Benz truck.
Yeah. So if you don't like the ongoing costs, then I would say have a slightly smaller system. Maybe instead of a 300-gallon reef, maybe you should have a 75-gallon reef. But at the end of the day, when you're putting a reef tank in, I think that it's important to think also not just about the setup cost, but about the ongoing maintenance cost, and to put in a system that gives you the appropriate ongoing cost so that you're happy with maintaining this reef tank in the way it should be maintained. Mm-hmm. The other thing I'll say about that is that people think nothing about spending $300 or $400 on a little tiny coral frag, but they worry about $5 extra for this additive or $5 extra for this bucket of salt. If you buy one less coral frag a year, you can keep your animals in the best thing possible. Mm-hmm. You have to remember that the water that you're creating for these animals to be in, this is the life breath of these animals. These animals live and breathe this water 24 hours a day, 7 days a week. You want to put them in the best possible, pristine, beautiful solution that you can possibly put them in. It makes no sense to buy this expensive coral and then go and get the cheapest additives you can get to put in the tank. So I would say the difference between the cost of the balling or the Reef or the carbocalcium is so small that the much more important factor is, how do you want to keep your reef? Do you want to run 1 or 2 dosing pumps where you have very little control over the individual components? Or do you want to run 4 dosing pumps where you have complete control over each of the components going in? That's your choice. And that, to me, is more important in thinking about what product you want to use than the actual cost per gallon of the product.
Okay. And people sometimes say that big companies sell cheap compounds in bottles with 1,000% of price.
Yeah.
on top of it.
It sometimes happens too, but I think the methods that you want to use in your reef tank are more important to think about than $5 one way or the other in the cost of a product.
Okay. Okay. So, question for me. I watched your video from Reef channel. It was in 2019, and you told that probably it's not possible to create a powder form of Alpha Reef because you can't make dry trace elements. But now
Yes.
we have it. So what changed
Yes.
since that?
We actually figured out the method to do it. The problem was in these very, very tiny concentrations of the trace elements. It was not possible. We didn't have the method for figuring out how to get these into the powdered form in there. And we came up with a development, it's proprietary, but we came up with a development that allowed us to do that, and everybody was asking for it. And we had been doing the research to try to figure out how to do it. But when at the time that I did this interview with Reef dudes, we didn't have this method formalized. And then we found the secret to exactly how to do it. And this was the result. I mean, everybody was asking for the powder, so we were working on it. But it just took us some while to figure out how to do it.
Oh, that's great. So powdered Alpha Reef and liquid Alpha Reef are completely the same?
Absolutely 100% the same. Once you use the powder mixed with, when you add the powder to the proper amount of RODI water, the resulting solution that you get is exactly what you buy when you buy the liquid Alpha Reef. It's exactly the same.
That's great, because I'm switching from liquid to powder.
Yeah, it's exactly the same. You will notice that sometimes the powder that you mix up has a color. Sometimes it's a little yellow or a little brown. This has to do with one of the components. It's not a problem. It doesn't change anything. But sometimes when you mix the powder into the solution, it comes a little different color than what you get in the bottle, but it's exactly the same components.
Okay. And some people ask, is it possible that the powder does not dissolve completely in the required amount of water?
Yeah, when you're making the Alpha Reef solution, you're making what's called a supersaturated solution. So that means that the way we have it designed is that you are putting absolutely 100% as much powder dissolved in the solution as possible. And depending on other factors, maybe a little bit of that can't dissolve. And sometimes you do have a tiny little bit of residue left, but in this case, is no problem. The concentration of the solution is always correct. And if a little bit of this powdered stuff on the bottom got sucked up into your doser and went into the tank, it wouldn't hurt anything. It's just because this is a super saturated solution and we're right on the edge of how much powder will go into solution. So sometimes there's a little tiny bit that doesn't. It's not a problem. And
also the same question is often asked about bulling components. So, for example, some people buy bulling components from local Russian store and it does not dissolve completely, and they say it's a fake bulling.
Usually it's only the bulling B that has sometimes a little bit of residue for the same exact reason. We're going right to the supersaturated level of that. I have not seen it happen with the bulling A or the bulling, certainly not with the bulling C. The bulling C is in such a small concentration, dissolves no problem. The bulling A, I've never seen it make a residue. The bulling B sometimes makes a little residue because it's very, very close to that supersaturated level.
So it's okay.
Yeah, it's also not a problem if you see that.
Okay, thank you very much. Let's go and continue with trace elements A- and K+.
Yeah.
What is inside these bottles?
Well, so out of the 70 trace elements, I told you before, there are 17 of them that go down very quickly in reef tanks. You don't really want to supplement all 70 trace elements. You want to supplement the 17 or so that you know are getting used. We don't even know what all of the 70 trace elements do. We just know that these, if you have 10 reef tanks and you look at the trace elements over time in these 10 reef tanks, some will use other trace elements. There will be others that go down in other tanks that are different, but all 10 tanks will have these same 17 trace elements go down. So what Tropic Marin does is that we separate those 17 trace elements into the 7 negative ions and the 10 positive ions. The reason we separate the ions is so they don't precipitate. This is how we can make a very highly concentrated solution that doesn't precipitate, because there's nothing for it to bond to. An ion is just a molecule that has a charge on it. Molecules don't like to have charges. So they bond. If it's a negative thing, it bonds to a positive thing, so it's neutral. When it's an ion, it's got a charge, and so it's always looking for something to bond to. What we do is we separate the positive and the negative, so there's nothing in there for it to bond to, so it stays in solution. This is why you can't mix them together, because if you mix them together, they bond, and then they fall out of solution. They precipitate. Okay? So I have a list here because I never remember what is in what. The A elements is all of the negative ions. This is bromine, fluorine, iodine, lithium, molybdenum, selenium, and vanadium. Those are the 7 negative ions. And then the K elements are the positive ions. The reason we call them A and K is because A stands for anion, which is negative ion. K stands for cation, which is positive ion, okay? So the K elements are barium, boron, chrome, iron, cobalt, copper, manganese, nickel, strontium, and zinc. So those are the 10 positive ones. So that's what's in each of those. Did that answer your question?
Yeah. Okay. Can A and K elements be mixed with Alpha Reef? And does Alpha Reef has all the amount of 70 trace elements which are not used?
There's no need to add A and K to the Alpha Reef because they're already in there.
But if you need, for example, if you need more.
Well, I wouldn't use A and K. If you need more, you're going to need more of 1 or 2 specific trace elements. You're not going to need all 7 negative ones or all 10 positive ones. So, for instance, manganese might be one that you would need. And there's a lot of reasons for that. Strontium might be one that you would need. But I would choose to add those separately if you felt you needed them, rather than to use the A or K. And I would add them separately. I wouldn't add them, like I wouldn't add extra strontium to K. I would add strontium separately to the tank.
Okay, and how can you understand which elements do you need? For example, you see a problem with your aquapor coloration, and you think, I don't have... what?
Yeah, I tell you, it's when it comes to trace elements, it's extremely difficult. And the reason it's difficult is because things like manganese and iodine, for instance, these are things that get taken up by bacteria so quickly that it's when you're looking at an ICP test or even a mass spectrometer test of the water, you're looking at just a snapshot of time. You're looking at just a moment in the life of the tank. Your tank will almost never show enough iodine, for instance, or will almost never show enough manganese because it's taken up so quickly. For instance, well, let's talk about manganese for a second. You might do a water change with water that has, say, maybe 150 micrograms of manganese in it, okay? And you do your water change, and maybe this results in about 25 or 30 micrograms additional in your tank, okay? The problem is, if you wait a day to do your water sample for your ICP test, the manganese is almost gone now because the bacteria have taken it up so quickly. So this is true of iodine too. Iodine gets taken up very quickly. So it's very difficult with certain trace elements to know what you need to add. And this is why I think that a periodic addition of the trace elements that we know are being used is a good place to start. And then if you feel that, oh, my iodine is low, and it's always low, I'm going to add some iodine. Then you target just the iodine, you start adding just the iodine, and you see how your corals do. If you feel like the color improves, or they're more engorged, or they have their feeders out more at night or something, they're looking better, then maybe that was the iodine. Maybe they needed some more iodine. Maybe you try manganese in the same way, or strontium in the same way. I mean, there's certain corals that we know. I think Xenia is a strontium lover, and so it depends very much on your individual tank. But I personally am not a fan of this idea that if you want your corals to be more blue, you add more of this. I'm not saying that I don't believe that's true. What I'm saying is that these things exist in such small concentrations and they get used so quickly that I don't think we have the proper technology yet to know what those corals need individual trace element wise from day to day. I just don't think we have the technology yet to do that. I think it's fine to experiment with one thing at a time to see how the corals react. And you have to give each thing maybe a month at a time. You can't just look for one day. I think experimentation is fine, but I don't feel like we are yet to the point with trace elements that we have the technology fine enough to say, oh, you need to add more of cobalt to your tank on a daily basis. I just don't think we're there yet.
Okay. So trace elements are not like paints. You add one and you get the specific color.
Yeah, it's well, that's just my opinion. I know a lot of people think that.
Yeah.
I also know that there's some anecdotal evidence, for instance, that if you raise the magnesium in the tank, the coralline algae, a lot of people say with the higher magnesium, the coralline algae looks more purple. I hear this a lot. It might be true. And I think that there's some anecdotal evidence for certain trace elements making certain color changes. I just think that we're not at the point yet where we have the technology to be able to diagnose in your tank on this one day from this sample of water what you need to add to make your corals more red. I just don't think we have that technology yet.
What trace elements, what separate trace elements, additives does Tropic Marin have?
Well, we have the magnesium, which is not really a trace because it's in such high quantities. We do have an iodine that is unfortunately not available in the U.S. We're not allowed to import it, but I know it's available in quite other places. We have strontium additive, and I think that is it for trace element additives right now. We're working on others, but as of right now, it's just those.
Okay. So you also in some of your streams, you told that you can use Lugol's solution to add iodine. So you can go to the next drugstore, buy Lugol's solution and use it?
Yeah, except I was just told by Hans Werner that Lugol's is not the best way to add iodine to the tank. So I'm going to retract that statement. And because we don't import, we have an iodine bath, Coral Clean, that is for aquapora, for flatworms. But because we don't import an iodine additive to the U.S., I don't know a lot about the iodine additive, what is the best way. And I always had thought it was Lugol's, but I was corrected by Hans Werner the other day. He said Lugol's was not the best way to add it.
Okay, it's strange because on Tropic Marin website, in iodine additive, it is told that it is Lugol's solution.
Yeah, I have to ask Hans Werner about it. He was explaining something to me about it, but again, because I apologize, but because we don't import it here to the U.S., it's not one of the products that I focus on, so I don't know a lot about it. But I could find out from Hans Werner for you
yes,
what is the best way.
Because a lot of people asked me about this, and it's very important and interesting question. So in trace A solution, it does contain iodine, and it is in another form, not Lugol.
I believe that is correct. It is in another form, not Lugol's.
Does trace element ENG contain chelates?
No.
No. So
No.
All elements are in ionic form?
Correct.
Okay.
And that's how we keep them from precipitating.
Okay. So I think that's all. We finish with elements. And let's go to another topic. This topic is Tropic Marin way of setting up a new reef tank.
Yeah, I'm going to hedge a little bit on this because we're actually in the process of putting a guide together to really show one good way to do this. But I do have some statements that I can help you and make about this.
Maybe this is from your experience, and you can tell more about your experience of.
First of all, I think there's a lot of different ways that you can be successful.
Yeah.
There's no one perfect way to do this. I think you can set up a reef tank with any of our salts and get it started with any of the salts that we make. A lot of people ask me about sand bottom or bare bottom or coral rubble bottom. I'm a big fan of a thin substrate in the tank. I think that it adds a lot of surface area for the growth of beneficial bacteria. I don't like to see thick substrate. And I think it's perfectly fine to go bare bottom if you want to. But if you're going to go bare bottom, I think it's more important to use live rock. Because again, you don't have the growth of the surface area for the growth of the bacteria. Do you need live rock in all instances? I don't know. I was just talking with Hans Werner about this day before yesterday. And one thing that I learned that I really was very interested and had to do a lot of research about is that I was always under the impression that when you're cycling a tank, that you introduce nitrosonomus and nitrobacter, and that the nitrosonomus is what makes the ammonia into nitrite, and the nitrobacter is what makes the nitrite into nitrate. It turns out that's not totally the case. It turns out that archaea is much more important in the ammonia to nitrite phase. And you can get the archaea from anywhere. You could literally start a tank by going outside and taking a tablespoon of soil and dumping it in the tank. You could literally start a tank like that. The archaea will multiply given the ammonia as a food source, and you're off. You're good to go. So I think that the debate of live rock or dry rock also kind of falls into what is the approach that you want to take. I personally like cured live rock because I think the more biodiversity that you can start out with in the tank, the better the tank is going to do. Now, there's a lot of talk about if you start with live rock, you're going to go through this cyanobacteria stage and dinoflagellate stage. I think you're going to go through that pretty much anyway. And I think that you just have to be prepared for it and you have to deal with it. You have to know it's coming and don't be surprised and understand that it's part of the natural maturation of the system. And instead of being angry about it and getting frustrated, be happy that the tank is maturing the way it's supposed to mature. It's going to happen. You're going to go through it, so you might as well just go through it. I think that products that we make that are very helpful in getting a tank started, certainly you need one of the salts. I think the Reef Actif is a very good product to help get a tank's bacterial population going.
So you can start adding it from the beginning.
The Reef Actif, absolutely, because all of the beneficial bacteria that you want to grow are all the kind that eat and get nourished by the type of carbon chains in the Reef Actif. So you're really giving the good guys what they need to get going when you use the Reef Actif. I think nitrobiotic is a helpful product in the beginning because it introduces more of that beneficial bacteria and also some of the purple bacteria, which helps override some of the anaerobic activity that goes on in the tank. And I like using Trace A to help start a tank as well, because iodine is very crucial in the beginning stages of a tank. And the Trace A gives you that iodine that is so important in the beginning of a tank. You were asking me about water changes in the beginning of a tank. I am not one of these people that says you can't do water changes during your cycling because you get rid of all the bacteria. I don't agree with that. I think the bacteria largely lives on your rocks and substrate. Is there bacteria in the water column? Absolutely. Is that the bulk of the bacteria? I don't believe it is. I believe that the bulk of the bacteria is on your rock and in your substrate, and that's where it's going to stay. And so you could do 100% water change if you want. I don't think it hurts your cycling. I really don't. I know there's a lot of people that say you can't do a water change during cycling. I do not agree with that. I think you can change as much water as you want during your cycling. And in fact, if your phosphates are really building up very high, or your nitrates are building up very high because of the cycling, get some out of there. Do a 50% water change and get rid of some of it until your filter bed catches up. Then when your filter bed catches up, then all you're going to end up with is a bunch of nitrates. Again, water changes to get rid of them.
Sometimes people say that alkalinity can be consumed when a new tank is studying. Have you heard about this?
I've heard of it. I've never really seen it happen in a bad way. I have heard this, but I personally have never seen it.
Okay. Which salt can I use? Which salt and when can you use from Tropic Marin? For you have 3 salts: Pro, Reef, Bioactive, and Symbiotic. What is the difference?
We also have the classic. We have 4 salts.
Classic.
Yeah, I think you can start a tank with any of the salts. I like the bioactive salt for starting a tank because then you're giving it the Reef Active at the same time. But you could use the classic if you want a higher alkalinity, or you could use the Pro Reef if you want a lower alkalinity and you want control over the Reef Active going in. You could use the Pro Reef and add the Reef Active manually.
And what about Symbiotic?
Symbiotic is, you could certainly start a tank with it, but the real benefit of the symbiotic salt over the bioactive is for the vertebrates. And until you have fish in there, it's not going to do much additional for you. So I think that it's not necessary to go to the symbiotic until we have fish. Once we have fish in there, the symbiotic is very helpful for the digestive tracts of the fish. But in the beginning, before there's a lot of fish in there, I don't think it does much to help you.
Okay. When can you start putting corals and fish in your new tank?
Oh boy, that's a tough one to answer. Well, first let me say, I really believe that all fish and corals should be quarantined before they go in your tank.
Okay.
Old tank, new tank, doesn't matter. If you don't quarantine your fish and your corals, at some point you're going to introduce some type of bad guys, parasites. And it will happen, and they will be much harder to get rid of in your tank than they are in the quarantine. So I really think that if you are looking to have a successful long-term reef, I don't care if it's a 5-gallon nano tank or it's a 500-gallon mixed reef. If you're looking to have long-term success, you really want to set up a little 5-gallon quarantine and quarantine your fish and your corals. Dip all your corals and quarantine them to make sure there's no bugs on there. And I just yeah, sorry, go ahead.
How long should the quarantine be?
At least a couple of weeks, if not more. I think the longer you quarantine them for, the more chance you have of finding a problem. But minimum 2 to 3 weeks. And if your fish are still healthy, not showing any signs of any gill issues or any white spot, or they're eating well, chances are, if they're not showing any problem in 2 to 3 weeks, they're probably okay. Your corals, if you dip them and you're not seeing any eggs, you're not seeing any red bugs or black bugs or whatever, usually that stuff's going to show up in 2 to 3 weeks. If you're doing your quarantine in a bare bottom tank, normally you'll see a bristleworm or a bristle star, or some little bad guy will come out at some point and you'll see him. So minimum 2 to 3 weeks. If you wanted to go 4 or 6 weeks, I wouldn't argue. Okay. And then when can you put them in your tank? How soon can you put them in your tank? That's a tough one because you need the animals in the tank to get the cycles and the biodiversity going in the tank. Mm-hmm. At the same time, if you put them in too early, you're going to stress them out. Yeah. So it's a hard call to make when you can put them in. I think that as soon, in my own personal opinion, right at the moment, then I could change this opinion at some point. But right at the moment, my feeling is that when your tank cycles, so you clearly see your ammonia go to nitrite, and then go to nitrate, that when that cycle is done and your ammonia is close to zero and your nitrates are close to zero, mm-hmm. Sorry, your nitrites are mm-hmm. close to zero. In my opinion, that's when you do a water change and you get your and you get some new animals in. Mm-hmm. The reason I like to do it then is because your filter bed, your nitrification cycle, has built to a certain point. And if you don't nourish it with more ammonia and more nitrites, it's going to go dormant. Mm-hmm. So I like to put something in the tank at that point to keep that cycle growing and going. At the same time, I think that when tanks are very new, adding animals more slowly is always better than adding animals more quickly. Mm-hmm. So I think it's good to add a fish or two mm-hmm. and a coral or two right after that cycle. And then when everything is still stabilized a few months from then you can start adding some more fish and corals very slowly. In my opinion, it should take probably a year to get to a point where you're really feeling like your tank has a decent population in it. Mm-hmm. I don't like to see when people call me and they're having trouble and I ask them what's in their tank and they describe all these 50 coral frags and 6 clownfish and 3 big anemones, and I've got a yellow tang and a surgeonfish that's 6 inches and this and that. And then I say, how old is your tank? And they say, 4.5 months. I'm not a fan of doing that. I think it's too much. I think you have to really, I think the more slowly you build the population mm-hmm. during the first year, the more stable your tank will be. Okay. And I'll say one more thing about new tanks. I think the first 6 months, we know what's going to happen, and it's like the honeymoon. It's very easy to keep for the first 6 months, and we know we're going to get cyanobacteria and dinoflagellate. Just let it happen. Let the cycle run. Mm-hmm. Between 6 months and about 1.5 years, that's the nightmare stage. That's when you really feel like you're fighting with the tank. You're always messing with parameters. You're trying to figure out how do you want to do your dosing, and everything you do seems to not work and you got to change it. That first 1.5 years is really, you really have to have a commitment and enjoy messing with the tank and figuring out what this system wants you to do. Mm-hmm. And if you can get past that first 1.5 years or 2 years, once you get into the 2 year and on part, that to me is when you really start enjoying the beauty of this thing that you created.
So it's quite long term.
Yeah, I think a reef tank is a long-term commitment. Mm-hmm. I really do. I don't think it's something you set up and 6 months later you sit back and you say, wow, that's beautiful, I'm done. I really think it's a long-term commitment. And from what I can see from a lot of people doing their tanks, mm-hmm. it really takes about 1.5 years to get to the point where you can really start to sit back and feel like you found the sweet spot of your additives and of your regime, your cleaning and your dosing and all of that, your feeding. It takes about 1.5 years to figure out what that tank is telling you it needs. And I put it that way because I think each tank tells you something different, and you have to be prepared to listen to your tank and your system and try different things to figure out what's going to work in that particular system. Too many people go into this thinking they know how they're going to do this tank and they're going to make it work like that no matter what. I don't think that's the way this works.
Okay. What else? Have you ever tried some kind of ceramics or dry rock to make your escape tank?
I personally have not. I know a lot of people that do, and I think it works fine as long as you make sure that you're introducing that beneficial bacteria, that archaea, which is not bacteria, by the way. As long as you're introducing these organisms in some other way. And that to me is very important. I don't think it's possible to start with a ceramic or an artificial aquascape and expect the tank to get bacteria from nowhere. The bacteria has to be introduced somehow. And like I said, you literally can take a spoonful of soil and throw it in the tank. That's okay. The bacteria will grow. So many people say to me with a tank that's 1 or 2 years old, what type of bacteria that I have to add? I don't think you have to add any bacteria after 1 or 2 years. It's all in there. You may have to give it the food that it needs to grow, but all the different types of bacteria that you need are in that tank. The minute you add a fish and some corals in there, you've got the bacteria in there that you need. It's all coming in on there. But if you're going to go with an artificial reefscape, which can be beautiful, you just need to make sure that bacteria is getting in the tank some other way.
Okay. Some people do this thing. They in old major tanks, they sometimes change some live rock with fresh one to introduce new stems of bacteria and so on. And they say it gives good results.
Yeah, I don't think that's a bad idea. I'm not sure that it's 100% necessary. I'm not sure that there aren't other ways to do the same thing, but I also don't think it's a bad idea. I mean, anything you can do to increase the biodiversity of this tiny little ocean system you've created is going to help. So if you introduce a big chunk of new live rock and you throw it in there, just make sure you quarantine it, because if you don't quarantine it, you're going to introduce some bugs and some bad guys. So make sure you quarantine it and you get those guys off of there before you put it in there.
Okay. What can you say about so-called old aquarium effect?
Old tank syndrome, we call it.
Old syndrome.
I don't believe it's true. I think that this old tank syndrome comes from, or the idea of the old tank syndrome comes from one of two things. One thing is, when tanks are older, people sometimes get lazy, and they don't do the maintenance, they don't clean the filter, they don't do the water changes, they don't test the water. I think that it sometimes comes from laziness. And this is, in general, the old tank syndrome that we talk about has two components to it. One is usually a high nitrate level, and the other is usually a low pH level from acidification of the water. Both of those things are usually related to inadequate maintenance. I won't say bad maintenance, but inadequate maintenance. So is that on the tank or is that on the owner? Somebody got old and didn't care. And it's usually the person taking care of the tank. But there's another factor, I think, when you look at old tank syndrome. And that is that these tanks are not completely stagnant objects. They're living, evolving ecosystems. Mm-hmm. And what the ecosystem that you have needs today is not what that ecosystem is going to need 10 years from now. Mm-hmm. It's going to need something different. A good example of this is trace elements, for instance. When a tank is brand new, it doesn't really need trace element addition. It's not going to need trace element addition until about a year or year and a half down the road, when the animals are growing more aggressively and taking up those trace elements. They're going to need a different amount of trace elements 5 years from now. Mm-hmm. So I think sometimes this old tank syndrome thing happens because people think that what this tank needed 5 years ago doesn't change. Mm-hmm. And so they don't analyze the tank in the same way that they did when it was new. When it's new, you're looking for, what do I need to do to have success? Then you have success and you think you can keep doing the same thing and that's going to always make your success. It's not true. Mm-hmm. What makes your success today may not be what makes your success 5 years from now. So I put old tank syndrome on the tank keeper, not the tank. I don't think tanks automatically get old and die.
Did you see Richard Ross' video from Magna? It's called Right Kind of Lazy.
Oh no, I didn't see that one.
You should definitely look.
Did he agree with me? Or not?
Yes, I think he agrees with you, because he's kind of lazy. Is a big Apex controller with thousands of different switches.
Yeah.
And everything controlled.
Yeah, but at least you're watching it to see what happens and what it needs, and if anybody knows about it, he certainly does. And I don't know if you want to put a link or something to this article I sent you, but that's an older article, but I think it really lays out the symptoms and the causes and what it talks about old tank syndrome, I think in a very intelligent way, for people that want more information about it.
Okay, thank you very much. I think we finish with all our questions. You promised me to ask Hans-Werner Balin last time about glycerol usage as a carbon source.
Yes, and I did ask him about it, and it's quite interesting. Mm-hmm. So this is not true about NP Bactal balance or plus NP, mm-hmm. but it is true of a limit NP, mm-hmm. where could you substitute, you asked me the question, could you go to the drugstore and get glycerol and substitute it for a limit NP? The answer is basically yes. Mm-hmm. However, the finesse or the thing you have to figure out is what is the concentration mm-hmm. of glycerol that you want to use, and how does that translate to dosage? Mm-hmm. So could you substitute glycerol for a limit NP? The simple answer is yes. Okay? Mm-hmm. If you can figure out because if you go to the drugstore, you're going to get glycerol that is either like 88% or 95%, something like that. Mm-hmm. This is not a limit NP. A limit NP is engineered to a certain dosage. Okay. And so you have to figure out what does that 88% mean for you to dose in your tank to ensure that you're not overdosing or underdosing the glycerol.
Mm-hmm.
But can you use glycerol instead of Elim NP? Absolutely. That's what it is. Mm-hmm. As long as you can figure out the dose and the concentration. That's where the science, the aquarium science comes into it.
I see. Okay, thank you very much for getting this answer, because a lot of people asks about it. So Lou, thank you very much for taking part in this interview. It was great to speak to you. Sorry for my crappy English.
No, listen, your English is fantastic. My Russian is non-existent. So all I know is da, and I don't know any Russian at all. So
borscht, you know borscht.
Yeah, borscht. Yeah.
And vodka.
And vodka. That's about it. So your English is excellent, Alexei.
Thank you very much. Have a nice day. I think we can see you one more time, maybe when we get another questions.
Yeah, you can always set something up with me, or send me email questions. I will send you an email about the iodine.
Iodine, yeah, it's very important thing.
I'll ask Hans Werner about it. And if you get a group of questions together that you want to ask me, we can do another video. And when you get the editing done of these videos, send me a link.
Yeah.
Because sure. I love to see. You said you're going to post the English version in Reef to Reef.
Yeah, exactly.
But I like to see the Russian version.
Okay.
I did a video. Somebody in Russia dubbed Russian over my video, my product video for something.
Yeah, BSK company, which is a Russian distributor of Tropic Marin, did the translation. Yes, and they posted.
Yeah, and it was really funny to see me speaking Russian. It was great.
It will take some time to make a translation, because it's quite a difficult thing, and I think English version of video will come soon.
Yeah. No rush. I'm just curious. When you do it, send me a link.
Sure. Thank you very much.
All right, Alexei. This has been great, and always let me know if I can answer any questions for you.